Hello, this is part 6 of our game making tutorial for beginners. Last time we added sounds, and I added the most deafening, annoying machine gun sound in the world. And we also did a bunch of basic stuff to do with frame rate and making the background nicer and stuff like that. This time, right now the player can't die, so I feel like that's the biggest thing wrong with our game. It's a question you should keep asking yourself: is what's the biggest thing wrong with the game? To some extent, I'm doing it in a slightly different order that I normally would, so that we can teach several different concepts rather than going back over old territory. But the player should be able to die. That's a thing that should happen. So one thing we could have is just when the enemy touches the player, it destroys the player, and then when the player is destroyed, we have maybe some game over message or something, and you press restart to restart. Hopefully, most of that you should be able to do by yourself if you want to, like certainly having the player just be destroyed by being touched. And we already have the restart key, so displaying some text on screen, we'll get to that at some point. But for now, I actually don't want our game to work like that. I'm more interested in can we make death a thing that you recover from? Can we make it more of a thing that's annoying, or it's in some way disadvantageous to you, but it's not a fuck, I got to restart moment. So my thought about this is just anyway, for purely visual purposes, it would be great if when you died you exploded. I think that's just logic, isn't it? If something explodes, that's better than it not exploding. So the first thing we'll do is make the player explode, and then my thought after that was well, after you've exploded, you'll be in bits all over the floor. What if those bits could reform somehow? So maybe you control one of the bits, and that has to go around and pick up the other bits, or maybe the bits just all drag together over time. We'll mess around with some code and see how that works. So the first thing we'll need is a sprite for the bit, and actually I'm going to base this one on the player, so we'll just duplicate the player. And we don't want to put too much work into this because we might change the look of the player later, and then all our work making little bits of the player would be gone out. Let's get a very small eraser brush, turn the hardness up, and to make a thing that looks like a chunk of the player, we can just cut a chunk out of the player, right? Gosh, that's maximum hardness, but it's still not completely hard. Something like that. And I've done this a bit wrongly because we want it to be facing right, of course. We'll rotate it, because you just draw things facing right for whatever reason. And we just want to crop it. Can we do that here? Yes, we can. Oh, that's good, because we can see that that's not quite right, is it? There's probably some semi-transparent pixels somewhere that we're not seeing. We don't care about those. So can I trim it to that? I don't know. I know what I can do. I can copy that, I can select all, then I can delete, then I can paste, then I can transform, then I can crop. That's how we get rid of the transparent pixels, rather than just going over it again with an eraser brush. It matters a little bit where the center of this is, but it doesn't matter if it's not at the exact head of the chunk or whatever. What should we call this? Yeah, let's call it player chunk. And we'll need that to be an object, so we'll create a new object. Hopefully the bits I'm going over quickly are the bits you don't need, the way I did that sprite is not important, just do your own sprite however you like. And we'll make this player chunk, and this stuff about creating objects is all stuff you've done before. Select the sprite, like I often forget to. And now we'll say okay and just leave that as it is for now. We'll drag it. You can drag things around in this hierarchy, and having it next to the player makes a certain amount of sense. Double click on the player, go into a step event, and so let's put in death. Again, it's not mega important in this case, I don't think. Maybe it is. But as I said last time, more important things should go towards the bottom. And so we're going to put death around here. Maybe it should be the actual final thing in the code. Just because if anything up here messes with your position or any of your properties, then we want it to be overridden by this stuff later on. For most, once you've done a lot in a step event, for most steps, most of the stuff is not executing. W, S, A, and D aren't all being pressed at once, and fire is only being pressed some of the time, and going outside the room is very rare. So, it's not like every line of this is always being executed. It's just a bunch of checks are going to be run, and the most important ones go at the bottom because they will override the other ones. So let's do it the same way we did before. Do we need to? I'm trying to think if we need to know, if we need to have the ID of the thing that killed us. We might as well, just for consistency's sake, rather than teaching a whole new thing. So say enemy touching me equals instance place x, y, o enemy. So that says create a new variable called enemy touching me, look for something that's at my location, x and y, of the type enemy. And if you find one, then store it as this. If you don't find one, then it'll just return like -4 or something weird. Either way, the next thing we want to do is say if, sorry, I didn't mean to paste that just yet. If instance exists, enemy touching me, then we want to die. It's that serious. I am going to put this at the very bottom because you can get into some weird situations if, if you destroy the entity that's running the code midway through the code, because the rest of the code actually still executes. So then when we try to say, if our x value is less than 0, GameMaker would crash and say, I don't know what your x value is because you're destroyed. Although it will say it in a way that might make it a little harder to understand than that. Okay, so if there is an enemy touching me, for now we're just going to blow up on the spot. And this is going to be great. I'm going to teach you loads of useful stuff here. Basically, this is going to involve a lot of things that are very common, very commonly required that we haven't covered yet. So we want to create a bunch of bits flying in all directions before we destroy ourselves. So we know how to create an instance, right? It's instance create, not instance crate. But we don't really just want to type out, like, we don't want to copy and paste that line, 3 times or whatever, or 10 times, or however many bits we want. It would be great if we just had a variable for the number of bits that we could then come back and change if we decided there were too many or too few. So let's do one of those and say bits equals, try 6 at first. Good to err on the side of too many rather than too few. And now we want to create a number of bits. We want to do that instance create thing 6 times. And for that we're going to need a loop. And there are loads of different ways of doing loops. But I said at the start of this tutorial, we're going to do things the sort of cheap and dirty way. And one of my objectives is to learn as little syntax as possible, like all these special words and special terms and structures and ways you have to lay things out. For me, those are the burden, those are the difficult part of learning something. So I've got to remember that you've got to write it this way in that situation. This certain function works in this way, but this one doesn't. So I want to keep things as consistent and simple as possible. So we're going to use the way of doing loops that I use, which is while. So we're going to type this word while, and we are going to say, let's actually also define a variable here called bits created so far. And we're going to say 0 because we've created none of them so far. Some programs will be wincing at this because this is a very... The other type of loop you can do is much more designed for what we're about to do, but I prefer to just learn one kind of loop and use it for everything, because all of them have little quirks, like little things that can trip you up, that if you forget about them, crash your whole game and break things in spectacular ways. So if you only learn one way of doing loops, then you can get completely comfortable with it and know for sure how it works all the time. So we want to keep creating things while a certain thing is true. What is that thing? Well, we've written our variables quite clearly. Actually, let's be even more explicit, just so it's totally clear what we're doing. Bits, let's say, total bits to create equals 6. Bits created so far equals 0. So while the number of bits we've created so far is less than the number of bits we want to create, keep doing this. And now everything in these curly braces will keep happening. So we should, let's do instance create x, y, o, what was it, player chunk. And after we create it, we want to make a note that we have created it. So bits created so far equals bits created so far plus 1. This is by no means the most, the shortest or simplest, like most compact way of writing this, but it is very clear. I think you can read it and you know what that says. While bits created so far is less than the total bits to create one, and then make a note that we've created one. And you know this will stop at some point because this is going to keep going up, and eventually it will be equal to the number of bits to create, and that will give us the correct number. You might be wondering why it's not less than or equals to. That's just because we start at 0. If you like, you could start at 1, but in this case that's very counterintuitive because the name of our variable is bits created so far, and we haven't created any yet. So we want to, this is all well and good, but right now they're just going to create right where they are. Oh yeah, the other thing I was going to say about the while statement, the reason I like it, the reason I think it's a good one to teach, is that it's exactly the same as the if statement, only it repeats. So when you're worrying about what to write here, this is just an if statement. It's if bits created so far is less than this, then do this. And then at the end of it, go back to the start and see, is that still true? If so, do it again. Is that still true? If so, do it again. So it's just a looping if, and that's a really easy way to remember everything about how it works. It does mean this bit is absolutely critical. Do not forget to increase the count that you're checking against. Whatever you're checking here, it has to be changing each time, otherwise this loop is going to go on forever, and that will completely lock up your game. So this is good. We're going to create 6 things, but we also want to send them flying out, don't we? So we already know how to do that, right? When we created a bullet up here, we remembered its name, and then we gave it a direction, and we gave it a speed. So we'll do exactly the same here. We'll just say new bit equals this. New bit dot direction equals, we want a random direction, so let's say random 360. That means pick a random number between 0 and 360, which is a random angle essentially. And new bit dot speed equals, we could give this the same as a bullet. We're going to fly out at the speed of a bullet. 600 whatever room speed. I'm tempted actually just to say like something like bit fling speed here and define it up there, just so that all of the variables, all of the kind of things that define how this is going to feel that you might want to change later are all in one place. So when we test this, if it's crap, we can look here and say, okay, we actually need 8 bits and we want it to be going at 900 pixels a second. But we don't know yet, so we're going to test that. But yeah, it's nice to have all of the kind of, I think of these as like, I don't know, tweak variables or kind of gameplay variables. They're not things like this random 360, which, I mean, we could change that, but the reason it's 360 is just a fundamental law of maths to do with the number of degrees in a circle. So it's not the kind of thing we're going to be changing all the time and thinking, oh, should it be 359 or should it be 0? So yeah, this should be correct, I think. We create one, we give it a random direction, we give it a speed of about the same as a bullet, and then we make a note that we've counted it, and then we go back to the start until we've created 6 of them. Oh yeah, and then at the end we want to destroy ourselves. Important to put that outside of the loop, because if we put it in the loop, then we would create one of them, then destroy ourselves, and we'd never get up to the back of the loop. Actually, maybe we would. I don't know, it doesn't matter. The logical way to do it is outside of the loop. Create all the bits, then destroy yourself. So I think that's all of it. So we're testing a lot of things here. We're testing whether that collision thing works, we're testing whether the loop works, and whether creating these things works. But they should just fly out much like bullets. Let's hope. Of course, they're going to fly infinitely. They're just going to fling out. Let's see. I'll wait for them to get a little bit further into the room so we can see them go in all directions. Hopefully. Yeah! Pretty spectacular. So the main thing wrong with that, I mean, it's cool, but I actually do think we need more pieces. I think it'd be better if we had loads. So where we said 6 here, let's put it up to 9. The speed, and maybe we could increase it a little bit, but it doesn't matter for now. So all of that code is fine, but what we want is for after they've been flung from you, they should slow down, right? They shouldn't just travel infinitely like bullets do. The idea is they're kind of being flung with a certain amount of force, but they're not actually flying through the air with the speed of a bullet. Not really. So let's open up the chunk. Always a good phrase to be saying. add a step event and drag some code in there from the control tab. And what we want to do is reduce our speed. Just all the time that we have any speed, we want to be reducing it. And should we do that by multiplying it, or should we do it by subtracting something? I think we should do it by... Let's just subtract it for now. I don't think there's any reason to do it geometrically. We'll see. We can mess around with this. So let's say deceleration. We are... Ooh, this is going to be interesting. Let's measure deceleration in pixels per second so that we don't have to worry about the room speed thing. So if we wanted our chunk is traveling at 700 pixels per second. If we wanted to stop it completely in one frame, we'd type 700 here. So that means that each frame we want our speed to equal speed minus deceleration divided by room speed. I'll put that bit in brackets because we want to have that calculated first, and then we want to take that off our speed. You could put the room speed up there. This makes more sense to me because at some point we might want to replace room speed with some other variable that that more accurately reflects the flow of time, and if we want to do something like bullet time, we could put a timescale variable in there, and I don't know, I don't think it actually makes any difference, so I'm going to stop talking about it. Point is, both will work. So we don't want 700 though, because that will literally stop us within one frame, so it won't be deceleration at all. So we want something that's probably going to stop us after about maybe a second. What do we want? Start at 700, we want to reduce it a certain number of times. Maybe I am getting the math of this wrong. Maybe it should be divided by room speed again. I don't know. We're going to have to tweak this, I think. Anyway, let's just try it as like 7 for now and see what happens. So that's just going to reduce our speed by a certain amount. I'm trying to think, what I'm trying to remember is how I do it in heat signature, because I got this working in heat signature. I can't remember when the room speed comes into effect. I think actually I do all of the speed stuff manually in heat signature, so I control everything about it. So that actually, we implode! Fantastic! That wasn't intentional, but it's great. And then we explode and we never come back. I don't know why we never come back, but that's fun. So, why is it showing me the player? I don't want the player. I want the player chunk. We should only do this if our speed is greater than. So I think I still don't really know what I'm doing with this, but let's do that way. Because I want this code to look as much like my heat signature code as possible, and that says if speed is greater than deceleration, then do this. And I don't think have we ever done an else before? I don't think we have. So we want this to happen if the speed is greater than our deceleration. If the deceleration is greater than the speed or equal to it, then we're just going to stop. So we want speed equals 0, and we just write else here. So it kind of joins on to the if statement, and that means that if it's true it does this, and if it's false it does this, as language would suggest. So that should stop the explosion. I quite like the explosion, so we might want to put it back at some point, but obviously in its current state it's not that great because it explodes. It explodes, implodes, and then re-explodes infinitely. Let's get ourselves killed again. Yay, they just slow down. That's good. I would say... Actually, we've got our R button to restart, so I can test this multiple times. I think they should start faster and decelerate faster too. I don't want them to fly that far away, but it should look a bit more spectacular. Oh, I changed the sound for the gun, by the way. So it's now a kind of weird, slightly wet noise. Much more puny, but kind of like fun. Sort of. Anyway, let's get that chunk to decelerate faster. So instead of 7, let's do like, let's actually do 20, so we're greedy. And then for our speed that we create them at, let's make that 1,000. Yeah, something like that. That's better. Feels more like us blowing up, doesn't it? They almost... It's too uniform, isn't it? They all go exactly the same distance. So you kind of see that they're in a circle. So maybe they should actually go even faster. And... like 1,500, and here we could say something like, oh yeah, we can do random range. Let's do random range. So if you just do random on its own with a number, then that's from 0 to that number. If you do random range, then we can do, let's say, bit fling speed times 0.5 all the way up to, and a comma, bit fling speed. So somewhere between half that speed and the full speed. So it says pick a number between those two. And do you want to increase deceleration again? Maybe a little bit. Bit more deceleration. This is tweaking and you shouldn't really spend any time on this. Yeah, that looks way better. I wish you would stop going to the top of the screen. It isn't, when you press restart, it doesn't do the same thing every time, but it does seem to always go up. Oh, there we go. Excellent. We could do a sound for that, couldn't we? Let's go and do a sound on VFXer. There is explosion. Here we go. Oh God, I'm going to turn this volume down. Hopefully the game volume is also quieter for you. Fucking hell. No, it resets it back to half every single time you do it. Great. Okay, just in case that is deafening, I'm going to open up the volume mixer and turn it down. What about that? That one sounded pretty good though. No, it didn't. That one's kind of fun. Explosion 7. We take mutate on it. It will completely go away. Ah, that's fine, let's do that one. Click export WAV. And yeah, explosion 15, that's fine. That's a descriptive enough name. And then we're going to import that as before. Insert sound. Going to click browse to find it. It's in the same place as previously. And we'll call this a player death. And now let's go over to where we were. Have the player play that when he dies. Or when she dies. Do that here, I think. Audio, sound, play. Nope, I got this wrong around last time too, didn't I? Audio, play, sound. A player death. Priority 1, pretty important. Loops, false. Now we'll test that. Yep, pretty quiet, but pretty good. Wow, seemed to go further that time. Oh, you know what's wrong with this? The bits aren't facing the right way. I didn't notice until now. They should obviously also be facing... They should be... Let's do this on the player, so the player chunk. While they're travelling, we should say... let's make it only while they're travelling. While speed is greater than deceleration, we'll do image angle equals... I think just direction, right? Because the chunky end is facing right, which is angle 0. So I think we just want that. And then once they've stopped, we don't want to be running that code all the time. So let's see. Yeah, that's better. You're saying that's better a lot. So what should the recovery mechanic be? Should these... We could actually like steer one and try and pick up the others. It might just be kind of tedious though. Like, it's a more interesting idea, but shouldn't let that get in the way of the game actually being fun. So I think maybe after once they hit 0, they should go into like a reassemble mode and then merge into the player again. So for that, let's add a create event, and we're going to give them a variable that is let's just call it reassembling equals false. When it starts, when they first fly out of the player, they're not in reassembling mode. By writing the word false though, see it's gone red. True and false are special words, and when you define a variable like that, you're basically saying this is just a true or false statement. It's never going to be like 5, or it's never going to be the word blue. It's always going to be true or false. And then in its code, we'll say, in this event where speed was not greater than deceleration, and therefore we stopped, we will say reassembling equals true, and all of this, we only want this to execute if reassembling is false. So I'm going to open these braces and put braces around this whole thing, and select it all and press tab to indent it. So this is now an if statement within an if statement, and you'll be doing lots of these. This comes up a lot. So when we create, we set reassembling to false, and then while it's false, we decelerate. When we stop decelerating, because we've hit 0, we set reassembling to true, and now we want to do something in that case. And so we could just do something as simple as I think actually when we set reassembling to true, we should also say direction equals direction plus 180, because we want to reverse them, right? And then I wonder if the fact that our speed is 0 is going to mean our direction doesn't get saved. Hopefully it won't. Hopefully that won't be like erased or anything. And so then when reassembling is true, which is the else part of this big if statement, we could say speed equals speed plus deceleration. We should create a separate variable that says acceleration, obviously, but for now that's the quickest, easiest way to write this. So to go through it again, when we're created, reassembling is false, because we're not reassembling yet, we're flying away from the player. Then while we're flying away, we're constantly reducing our speed by deceleration. Once it gets low enough that we're ready to stop, we stop, and we set reassembling to true, and we spin around 180 to go back in. I don't change the image angle here, I'm just changing the direction. Direction is about motion, and image angle is about appearances. So once all that's run, reassembling will be true, and then the next step, when the next frame of the game, we'll come back to this again, and it will say, oh, reassembling isn't false, it's true now, so we're going to skip to here, and speed will equal speed plus deceleration. And then they'll keep shooting towards where they came from, and they will of course go past each other and fly off again. Which is actually what happened the very first time, but this time, I wonder if, Yeah, the first code we had would have been perfect for this. We could have just stuck with that. Because it's complicated why it worked, but it was basically doing what we wanted to do. Obviously, not once they... Yeah, that works. Oh, but now because they go different distances, that's a problem. It looks great though, doesn't it? So how can we fix this? I think we could have them store their original position when you first explode, store where the player died, and then just head towards that. Once they reach it, they could reform. I'm just addicted to doing this. It's really fun. They look like little flying blades. I think they should damage enemies, by the way. I think they should destroy them when you do this. So yeah, let's store their location. When they're created, let's actually, now that this is becoming more of an object, let's go into the player's code and all this stuff about what we do when we create it. When we created the bullet, we wanted to kind of put all these properties on it ourselves. The player is basically telling the bullet what to do. This chunk, though, does kind of have an intelligence of its own, and I think it probably makes more sense to do all of this speed and direction stuff on the actual chunk. So we will just, in this loop, we will just create the chunks. And then we'll use, now that this player chunk has some create code, we'll open that up and we'll paste all this in here. So this could essentially just be our initial speed. Don't need a variable for that anymore. Oh yeah, we kind of do. Okay, let's just rewrite this so that instead of saying 1500, we say random range like 750 to 1500 divided by room speed, and we're just taking out the word new bit in all of this, and now we don't need that at all. So now we just say reassembling is full speed, random range between these values divided by room speed, and direction is a random direction. Oh yeah, and the other thing we want to do, the new thing, we wanted to say original x equals x, original y equals y. So we're storing the place that we were created. We remember our birthplace, because that's where we used to be. So that then, so far we haven't done any new code, we're just reorganizing things. Then what we could do here is make it so that once we reach that place, we reform the player, perhaps, once all the others are gone, or we stop there at least. So let's say if point distance from our current location, x and y, to our original location, original x and original y, if that is less than our speed, that means we're going to get there next turn, next step. And in that case, let's just stop right now. We're not going to have like a smooth deceleration, it's just going to go vroom. It's going to be a sudden stop. And then is that, we could test that now, or let's actually define this acceleration value. So acceleration, we actually want that to be much less than the deceleration, so let's make it like 5, and we'll use that here because that's bothering me. Speed equals speed plus deceleration is worrying. Speed equals speed plus acceleration, and then if that gets us close enough to where we originally came from, we just want to stop. And then what we want to happen is for them all to snap back in place, and then once they're all in place, we reform the player and destroy the bits. That code actually isn't as simple as I thought it was going to be, so let's just test it now and just make sure it's all working as we expect. This isn't really like a common task to need to do, have the player reformat fragments of itself, but it involves a lot of common tasks like loops and getting things to reform. Oh, that looks fucking great! That is so cool. Even without reforming him, it actually looks enough like the player that it all makes sense. So now, what do we want to happen next? We want the when the last shard clicks in, that's when we want the player to be respawned. Yeah, okay, we're going to define the number of bits the player is made of as being a kind of global variable, like something that the whole game knows about. So instead of defining it here, we're going to take that out, say okay to this, and then in our game object, in the create event of that, let's create a category for like, we'll call it like, I don't know, global constants. It's a bit of a grandiose name for what we're actually doing, but what we'll call it is number of bits the player is made of. Most long-winded variable, but also the clearest. So we'll say okay to that, and we'll go back to the player, and now it needs to refer to that variable rather than using its own thing. So here we'll say, instead of total bits to create, we'll say game dot number of bits the player is made of. So that's our global constant for how many bits the player should fling into, and also how many are required to reassemble him. And then what we need to do when we reassemble is I think the game object will count how many of them have been reassembled. So we already know, we can already tell when we're being reassembled. I'm going to get rid of some of this stuff because I've left too many things open. What is that? That's the enemy. I want the bits. Give me the bits. Player chunk. When we get back, when we reach the our origin, we set speed to 0. So this is the point when I'll put a comment in here. Original position. For some reason typing is really slow. I guess it's just because I'm recording. So here we set the speed to 0, but also now we want to let's also put this variable on the game object. We'll say ogame dot bits reassembled equals that plus 1. And then we also want to check that says if ogame bits reassembled is greater than or equal to ogame dot bits the player is made of. That's not actually the right name, is it? We should go and check. This is the only disadvantage of having my really long verbose variable names, is that the exact phrasing can sometimes be ambiguous. So I should have just copied that when number of bits the player is made of, that's it. Unfortunately, GameMaker doesn't auto-complete these things because you can define them anywhere. So in other words, if enough bits have reassembled that we have enough to make a player, then we will do instance create xy_o_player, so we recreate the player, and then we want to destroy ourselves, but we also all of us will be, let's just destroy all of them. So we're going to say with player chunk instance destroy. So that's the thing we've done before. We destroyed another object from within this object, but in this case we are saying we're not using a specific name like my bullet or monster touching me or whatever. We are using an object name, which means it will apply to all the objects. So every single instance of player chunk will be destroyed when we do that. So to recap, this says when we reach our original position, we increase this global counter for the number of bits that are reassembled, and then if that takes us up to the amount that we need to make a player, then we make a player and we destroy all the bits. Let's see if that works. Who knows? Obviously we need to actually define that thing about bits reassembled. That was a thing we made up on the spot, and now we need to go back and actually make it true. Bits reassembled is going to be 0, obviously. And in fact, we should even take the extra step of, after we reassemble the player, we should set that back to 0 for next time. so that it doesn't instantly respawn next time. This is a bit of a messy way to do it, but to be honest, this is like I've never really had to do anything like this before, where we're counting how many different objects are in the right position. There are loads of different ways to do it. I was trying to think of what the most logical one is, and I don't think there is a super neat and tidy one. So let's see if this one even works. Ooh! No, it didn't work. Why did that work? Oh, I know why. So we reformed too early, didn't we? And it's because we can count ourselves multiple times. This one thing could keep counting ourselves loads of times. So how do we do that? We're going to have to change. We're going to give ourselves a new variable that says the logical name is reassembled, but then we've kind of used that quite a lot. So let's call it in position equals true, and then this will be only if in position is false should we increase this, and let's even put that in there. So if we're not in position, if the variable says we're not in position, but this thing says we are, then count us and set it to true. And when we are created, we should set that to false. So in our create event, we want in position to be set to false. This is beginning to be a bit of a rabbit hole. Like, programming is full of like lots of things that are really simple, and lots of things that sound difficult and are actually quite easy. And then every now and then you get a thing that think, well, in principle that seems simple, but then when you come to code it, it's like, actually, how exactly does that work? I'm not totally sure. So, one by one, they all resemble, and then we turn into a player! That's fucking awesome! Oh, that's so cool. You can just imagine what a good sound effect for that would be. I'm not going to try and make one in this episode because I've probably gone on long enough. It just looks so great, I love it. We might want to make it slower to make it more of a penalty, and if we give our player like things he can pick up, like weapons and stuff, then probably you'll lose all of those in the blast. There's something so cool about this. Excellent. So that was a lot of fiddling and a lot of quite difficult logic. Just getting your head around it, getting my head around it was difficult. But hopefully it was worth it for a fun effect that now handles player death. And because so the logic of spending some time and having bits fly out everywhere and figuring out how that works is that now we can do that to the enemies. So in future the enemies can explode, and we'll probably do that next time.